It's a real pleasure to be here tonight. I wonder if you've ever heard somebody say that and then ask yourself, I wonder if that guy really is comfortable and wants to be here tonight. Or is it just a throwaway line? Let me tell you a little story. I was born in Springfield, Ohio, about 20 minutes to the east of here. I loved airplanes from the moment I was born, I believe. And this place has a very special meaning to me. Air Force Museum. And in those days, it wasn't this magnificent structure you have around you. It was a series of small World War II huts. And most of the airplanes were outside. You could touch and feel them, crawl all over them. And it was a very inspiring thing to me, and I never could get enough of coming down through Fairborn and looking through the side streets till I saw the Atlas missile and knew that this was where all the airplanes were at. Over the years, the past 50 years, I've come back here many times. I make it a point to stop here in the museum whenever I'm in the area, and if it's only 10 minutes, I'll whip through one of the exhibits or spend a couple hours here. So it's very much a part of me, and I'm sure that it's a very inspirational museum, one of the best in the world. So I was delighted when I got the invitation, and I am indeed delighted to be here tonight. First of all, you'll notice that Jeff lied to you. The title's different. I figured there were a few more animals that I need to throw in here to tell this story properly. So it's a bit more than just the Weasels and the Raptors, which are the endpoints of this story. What I want to do is put this all in context, because I had trouble with this thing when they first said they wanted me to talk about these three different airplanes. I said, well, gee, they're so different. They're really not tied together in my career. They're certainly not tied together as subjects. But the more I thought about it, I said, yes, they're absolutely tied together. And so I want to present it this way. If you think about aerial warfare, and specifically fighter aircraft, as in all weapons, there's a offensive capability and there's a defense against that weapon. And so that is true with aircraft. So, for example, offensively, it soon became apparent that the machine gun was going to be a primary offensive weapon in the aircraft. Offensive against ground troops, or you could shoot down another airplane with another airplane equipped with a machine gun. And you see it here in the Marine Saulnier. Here is mounted up on the cowling is a machine gun, one of the first applications in 1915. On the defensive side, you're always trying to get rid of this weapon, and so from the ground point of view, the simplest solution was you simply take a piece of artillery and you mount it on a chassis so that you can traverse and elevate quickly to point at the airplane, trying to shoot it down. And in World War I, it became known as Archie or ACAC. Today, it's called AAA. But those are the two fundamental starting points. If you look at it as a timeline with 1915 down here and 2015 over here, and I've highlighted the various major conflicts, World War I, II, Korea, Vietnam, and Iraq, Afghanistan down here. What you see is that first thread of the gun on the airplane and the anti-aircraft on the ground continues for the past 100 years, or will continue into the future, and are still integral parts of airplane design and defensive capability. But beginning shortly after World War II, and certainly past the Korean War, we began to see another type of weapon, and that is the missile, the guided missile. And on top of that, we began to see in Vietnam the ground-to-air missile. So now you see two additional weapons introduced. The main thing that's important here is that these original weapons, if you like the Geico commercial, got a technical problem here. Okay. These are ballistic weapons. In other words, you shoot them, and then it's up to God and gravity and aerodynamics to determine where that bullet goes. You shoot it and release it. The difference was now you get into what are called guided weapons. weapons with a brain, weapons that can actually chase you down, that when you jig and jag, they move with you and try to get to you. So it added a whole new flavor to the air warfare. So what I wanted to do is from this point is take you to Vietnam, where we encountered the kinds of guided weapons that were added later on. The real difference in these guided weapons is the weapons, certainly, but the radar, the introduction of radar, tying those two together. On the left, you see the Fansong, or the guideline missile. We call this a flying telephone pole, and I like this picture because there's a telephone pole right there. About 35 feet long, about a 350-pound charge that when it went off like a shotgun, throwing ballistic pellets out. So all I had to do was get close, and it could knock you out of the sky. What was different here was that now they could see you when you couldn't see them. A radar can look through the weather. A radar can work at night. A radar can work and detect you at very long distances where the human eyeball can't see you. So you have a situation for the pilot that is becoming increasingly dangerous because of the ability of the radar coupled with the weapon. I think the best way to see this is to actually see a demonstration of what this looks like. This is SA-2 sights. In Vietnam, the order of battle was to fire 2 missiles, first one and then 6 seconds later another. The booster goes off and there's a big plume of smoke that you can see, and then once the booster drops off, this guy's coming at you, and you can't see him until he starts conning in this particular case, and you finally start to pick him up. Watch the motions of this missile. Look how agile it is, and you just have a tough time getting away from something that can move in that manner. Now, the second missile's already on the way. I'm not sure what this target is coming into view up here near the top, but this is the target. I believe the target's actually something hanging probably for some parachutes, so it's a fairly static thing, but that missile is continually correcting and very agilely finally hits it. And interestingly enough, the second missile sees a chunk of material coming out right there and is going to go after that little chunk of material. So not too much is left. Boom, there, got it. Obviously, the impact in combat was tremendous. This is a very rare picture. A SA-2 SAM missile has come in, a beam the flight path of the aircraft, exploded, and it's hit the aircraft, and he's on fire, and will probably be ejecting very shortly. When we first saw this, it wasn't a surprise because Francis Gary Powers told us that these sort of missiles were around and could do us damage, but people didn't pay as much attention until we started losing airplanes. Initially, we tried to counter it by jamming the radar signal on the ground, but for fighters, that doesn't work very well, and we had to come up with other ways of doing it. So we came up with a Wild Weasel concept. Now, this is the Wild Weasel patch. You'll see it down on the Weasel, out on the museum floor. The air crews were first told about this. They said, look, here's our idea. We're going to get this special airplane fitted out. We want you Weasel pilots. We want you to go into the target site before everybody else, and we want you to have the missile shoot at you. And then while they're shooting at you, we're going to have the other guys come in with bombs. They're going to bomb the target, but they'll be so busy shooting at you that the other guys will get their bombs off and can leave. But you can't leave until they've left. So we want you first in, we want you to be shot at, and then we want you to wait around and only leave when everybody else is safe. And Willie Weasel was was supposedly the look on the face of the pilots when they were being explained that this is what you're going to do. And then down here, it's you got to be expletive me, and that became the symbol for the Weasel mission. Now, the airplane, this is the second type of airplane. The first airplane they used was F-100, but they finally started using F-105, and the reason was it was the standard bombing airplane at the time, so there were a lot of them. And they took a 2-seat version, and they put on jamming pods, which you couldn't use because if you used the jamming pods, then the radar couldn't see you, but you couldn't see outside the jamming signal yourself. So you had to basically turn those off all the time. And then we added some missiles. So these are radar-seeking missiles that can see the energy coming up from the ground site and home in on it. There was another one called the AGM-78, which is also programmable, could go after the missiles. But that's how we were supposed to defend ourselves against these guys that were trying to shoot at us. There were 2 crew members on board, of course, the pilot, and then this guy back here, who was called the Bear. I'm not sure where that comes from. Some people used to say, like a trained bear, you have them with a big chain around their neck and you yank them around. And so they were affectionately known as bears. You flew as a team. You never split the team up. And the reason was because to be successful, the backseat of the Bear had to interpret the signals from the radar and give you good information on where they were at. And together you both had to be able to try to evade that sinuous snaking missile as it came up towards you. So you actually got to the point where you read each other's minds and you knew exactly what had to be done, and that's why you teamed up and flew as a group of 2. I want to give you an example of how we work, just one example tonight. I wanted to show you what our missions looked like and compare it with something you may be familiar with, which is World War II. We were stationed at Korat, Thailand, and we would go many places, including Hanoi, and that distance, 424 miles one way. Just to give you a feel for it, from London to Berlin is 492 miles, so kind of a comparable distance of transit to get to the target area. We had 2 basic missions. We went in with the fighters to support the fighter strikes, but we also supported B-52 strikes. The B-52, most people don't know, was used for 8 years in Vietnam. So it was there from the start. They had a lot of missions under them. However, they were never sent into high-threat areas. Strategic Air Command was afraid of losing their nuclear strike capability. They really weren't supportive of these minor wars, which they considered Vietnam to be a minor war. So the B-52s were heavily used to bomb the Ho Chi Minh Trail, which you see here, and the tons and tons of bombs that rained down on this place made it like the surface of the moon. You can just see the amount of jungle salad that was made by the B-52s. That situation continued for most of the 8 years, and we spoke disparagingly of the B-52s because we didn't feel that they hung their necks out, and any time there was a threat, they would never go in. But in 1972, President Nixon was determined to end the Vietnam War. And we'd gotten the North Vietnamese to the Paris peace talks, but it was clear they were not serious about it. They wrangled about the size and shape of the table they were going to sit at, and never came to grips with the actual issues of how to end this war. So Nixon decided in December of 1972 that he was going to send the B-52s into then the most heavily defended target area in the world, and that was Hanoi, ringed with all forms of AAA and the surface-to-air missile, the dreaded SA-2. Now, let me give you a feel of what we're going to see in a few minutes here. The B-52 is equivalent to 12 B-17s in terms of bomb tonnage. So even though the numbers I'm going to show you may seem to be small, it's actually representing a huge number of the equivalent bombers used in World War II. The standard SAC maneuver was to fly 3 airplanes together called a cell, and they would stack them vertically and space them laterally so that their radar jammers would jam the signal of the SA-2. That was their primary defense against the surface-to-air missile, was jamming. They had to stay in this formation. If they ever deviated from it and lost the protection of the jammers, they were a huge radar target and could easily be detected and shot down. Here is a turn-off target of B-52s. They generally flew at about 35,000 feet. This is called a post-target turn. It's an exact 90-degree turn off the target. The reason they turn 90 degrees off the target because that's how the manual said to do it for nuclear weapons to minimize the blast. Unfortunately, we were not using many nuclear weapons in North Vietnam. It turned out that this was going to be a fatal flaw for the B-52s because they are not in that carefully orchestrated 3-ship formation, and they do not have coverage at all from their radar jammers at this point. Now, I'm going to talk about a very specific time. It was called the 11 Days of Christmas, 1972. It is considered, though, probably the last mass bomber attacks that we will ever see again. Strategic Air Command directed tactics based on the greatest fear they had, which was that two of these bombers might collide with each other and be destroyed. So what they did is they took the airplanes and they sent them all on the same route at the same altitude. But they split the force up of 129 airplanes into three groups, equal groups. The first group would go through with the cells lined up one behind the other. The crews called it ants going to a picnic. We called it ducks in a shooting gallery. So 1/3 of the force is coming in along this track, lined up one behind the other. And they would wait then 4 hours, and 1/3 of the force would do exactly the same thing 4 hours later. And then they'd wait 4 hours, and the last third would do the same thing once again. Now, the Vietnamese were not stupid. About the first three guys that came over there and over the run-in, they saw two things. They saw, number one, everybody's at the same altitude, and they're always flying the same track, so let's just aim right towards this area because you know where they're coming from. And also, exactly 1 minute before they're going to release, they open their weapons bay doors, their bomb bay doors, and suddenly, from a radar's perspective, they become huge. So SAC ordered them to open the weapons bay doors 1 minute. So they gave the North Vietnamese 1 minute of free time, coming straight and level into the target. And when they made the post-target turn in 90 degrees, they lost their radar protection again, and so they could shoot them again. And that's exactly what they did. It was a carnage on the first night, and then SAC went and did it the second night and did it again on the third night. And the results are horrific. Now, this is a graph, and bear with me, but I think it's a very illustrating. These are the 11 days of Christmas, 18 December through the 29th of December, each day. Each dot is the day, and the blue line is the number of sorties, right over here, that were flown. Okay, so on the 18th of December, 129 sorties were flown up here, and you can see the other days. This blue line right here is the equivalent of a 1,000-plane raid of World War II in terms of tonnage. So you can see that on the first day and the second day and the sixth day, we were actually larger than a 1,000-plane raid on those flights. Red goes with red. This red line is what SAC estimated would be their loss rate. And you can read it over here, it's 3%. The bar represents the actual loss rate. So instead of 3%, you can see what happened. The first night, it was a little less than 3%. Nothing on the second night. But the third night, it was almost 8% loss rate on the aircraft. And again, you can see here on the 27th, there was a fairly high loss rate. What happened was this. Remember, we had the North Vietnamese in Paris trying to get them to talk peace. They had such a field day here, they became stubborn because they believed they were winning. Strategic Air Command was so perplexed by what was going on here that they pulled the airplanes back, and the next 3 nights here, they moved the aircraft almost 60 miles away from Hanoi at targets that were not defended, and only sent in 30 bombers instead of 129. That also caused the North Vietnamese to figure, we've won. They won't even come near us anymore. So they were not in any mood to bargain. Nixon insisted that SAC go back in. But finally they got the message that the tactics were not going to work with ants going to a picnic, because it was going to be ants going to a slaughter. So they changed the tactics, sent in a huge force up here of 116 airplanes, and this is what it looked like. Here's Hanoi. These tracks represent streams of B-52s. You can see these guys are going this direction. The ones in white are going this direction. These guys are going here, and so forth, back and forth. All the airplanes were flying at different altitudes, obviously different tracks, and they all were going simultaneously. Instead of 8 hours, all the bombs were dropped in 15 minutes. The effect was devastating. The North Vietnamese simply couldn't react. They were overwhelmed. The interesting thing about all this, the ants going to a picnic was driven because they were afraid of mid-air collisions. Their own doctrine for nuclear weapons was this tactical method, and they wouldn't use it initially. So what we learned was this. SAC was a very regimented organization. You'll do it SAC's way or you're out of here. And that was good post-World War II, and it worked. But you can't be inflexible like that in real combat, and SAC was. Again, as I mentioned before, they didn't think the Vietnam War was an important war for them, and they didn't know how to fight a conventional war, nor did they have a doctrine to do it. The combat crews knew what was going on right from the get-go, but they, out of hand, rejected it, as did the commanders from Utapao in Thailand and Guam, who told them that we have to change tactics. So they were rejected by headquarters SAC. And that reason was because they had very little combat experience there. They had people who were book-driven, rule-driven, and when they should have been using the tactics like the ones you saw on the 26th of December, they didn't. And then use tactics like the post-target turn and the ants going to a picnic when they're unwarranted. And from my point of view, this is one of those times when bravery was the common thread for those crews. They pressed on amidst fire from the SAMs that was awesome to look at, obviously devastating. 15 airplanes were lost. Our job was to try to intercept the signal and kill the SAM sites. We flew at 17,000 feet. The B-52s were at 35,000 feet. We tried to fly underneath of them so we could, the radars would have to look through us and we could detect and kill them. But it turned out to be very difficult to do. They were barrage firing hundreds of surface-to-air missiles at the time. And the lesson is that when you use air power properly, it gets the job done, and if you don't, you squander lives and you squander resources. Okay, so that's Vietnam, and we're going to segue into the YF-23 and why the linkage is there. We talked about this before. We talked, and you've seen the effect of guided weapons. Weapons that can see you when you can't see them. It takes away your ability to operate in weather. It makes it difficult at night. And so when they can see you, it makes it tough. So rather than develop some new kind of super weapon, people started looking at the problem differently. Well, what if they can't see us? How does that affect the combat? And that's why about the early 70s, studies began, and by the time of the ATF, we'd really solved or the approach we were going to take. Everybody in this room knows what the approach is. We've known it since we were kids. Just as she mentions, somebody would probably pay a pretty penny for this baby, and people were willing because it seemed to be the only way out of that conundrum of they can see you and kill you. So people have been toying with this idea for a long time. There have been 4 recognized generations of stealth. This Horton 229 occurred late in the war, December of 44. It was flying as a prototype. High subsonic conditions, very maneuverable fighter, but couldn't go very far with the jet engines of the day. But has been proven recently it was virtually invisible to the radars of the day. Special materials, special shaping in Generation 0 stealth. Generation 1 is the SR-71 Blackbird, meant to penetrate the surface-to-air missiles of the Soviet Union. It had some rudimentary shaping that we know today as stealth. It was extremely fast, Mach 3 plus, but pretty much straight and level. It didn't carry a lot except camera sensors, but it could go long ranges supersonic. We get to the second generation, and you see airplanes that don't look like airplanes anymore. They look like a series of flat plates welded together, which is kind of what it is. The 117 Nighthawk is a high subsonic airplane. It's somewhat maneuverable, but it's not a fighter. Can carry a limited payload up inside the weapons bays and limited range, except all these later airplanes can air refuel, so they can go greater distances. These platforms are uniquely flat-plated, but they're not very much an aerodynamicist's dream. So people were looking for something a little bit more like an airplane. And the third generation looks more like an airplane, although it's a flying wing. It has smooth shapes. It's not made out of flat plates. The B-2 obviously is a subsonic airplane. Again, straight and level like the SR-71, carries huge payload and can go for long ranges. So the question is, if you look at all those characteristics, which ones are missing in a fighter? And that became the challenge of the Advanced Tactical Fighter, was to put all the pieces that we've seen in several airplanes into one airplane. Specifically, what the Air Force wanted, or what the service wanted, was it to be invisible, in quotes, and be omniscient. Now, what that means is, the highway patrolman that hides in the bushes or underneath the underpass with his radar gun, he's invisible to you from the eyeball. You don't see him. But with your fuzzbuster, he gives himself away when he turns on his radar, right? So he becomes visible because of the use of his sensors. What we were asked to do is, it's something to be invisible, like Wonder Woman, but you also got to be able to see the other guy and do something about it. So you've got to build sensors that you can operate and they can't see. It's the ultimate radar gun for the cop. And they don't have it yet. But that had to be done. It had to be highly maneuverable, just like the fighters today, or better. And it had to be able to go supersonic speeds for long ranges, something fighters cannot do because of the use of afterburner, which gobbles fuel. And you had to carry a lot of stuff up inside the airplane. So that's the boundaries for these airplanes. The ATF program started in the late 70s. There were 7 companies that put forth proposals for these kind of invisible, omniscient, maneuverable kind of airplanes. And in '86, Halloween of '86, they picked 2 companies to build and demonstrate these advanced technologies. We're going to talk about the airplane, but there were many other things like the avionics that were tested separately and shown to be possible for the future. So that happened in '86, and then in 1990 we flew the prototypes, which we'll take a look at here in a minute. There were 2 engines and 2 different airframes, 2 for Lockheed, 2 for Northrop, and they were all tested. Interestingly enough, of the 7 companies, there was a mad scramble for the other 5 who didn't get the contract to see if they'd get a piece of the pie. So there was a great amount of teaming that went together, so that Lockheed, General Dynamics, and Boeing joined up to build the YF-22, and Northrop and McDonnell Douglas joined up to do the YF-23. And then in '91, they selected the winner. So, talk a little bit about the flight test program. There were only 5 pilots that flew the YF-23. 3 of them were contractor pilots. 1 was an Air Force test pilot, and 1 was an Air Force operational pilot. Those are the only people that flew the YF-23, and then there were a separate set of pilots that flew the YF-22. So no pilot had ever got to fly each one of the prototypes by Air Force directive. And this is what it looks like. You know, it has a very distinctive shape. It was meant to replace the F-15, so you can see they're fairly similar sizes. And just for reference, here's the F-16, which is a air-to-ground primary type of fighter aircraft, but a smaller aircraft. The airplane has the trapezoidal shape, and it has these V-tails. And I always found it interesting that to really understand what these V-tails look like, if you took them and laid them flat like the wing, they're huge. They're almost as big as the main wing. And what's important is this is an unstable airplane. Without computers, it would flip out of control. But you put a large tail on like that and an unstable airplane, and the airplane becomes extremely agile. It can point and maneuver extremely well. And the YF-23 certainly did that. From the side view, the airplane has the sleek lines, kind of an SR-71, and you can almost intuitively say, boy, that's a pretty sleek design. And in fact, it had a very low drag, so that its speed without afterburner was the highest of all the ATFs. And of course, you can see it here on the plan view, and it looks like a totally different airplane. These are called edge-aligned planforms. If you look at this angle, and that angle, and that angle, and that angle, they're all parallel. And that's important from a radar reflectivity point of view. It cuts down the radar return and helps you to be invisible. I use invisible because, in fact, these airplanes can be seen, but the equivalent is looking at a bumblebee. in flight. And that's what you're looking at. So they're extremely tiny from a radar cross-section point of view. We learned several things from the airplane. We had what was called the picture window effect. You can see the big tails here laying off the side. And in any other airplane, F-18, F-22, with twin tails, what you'll see from the cockpit looks something like this. You'll see these two vertical tails sitting up there. So when you're looking to the back, or what we call check and six, these guys are always here. And you get used to it, but surprisingly they are blocking your vision. And when you do it like that, the airplane has this unreal or surrealistic effect of just being an open window behind you. It was something new that none of us had ever seen. It also, if you look at test airplanes, you see about a 12-foot long pitot boom or tube coming out the front of the nose, and that's used to sense air data when you don't know what it really is doing on a first airplane flight. This airplane doesn't have that. All the sensors were mounted on the skin of the airplane, and it just simply sensed the air around the airplane, and by computers to determine airspeed and altitude. I was really nervous about that, but the engineers convinced me they knew what they were doing, and they did. It worked very well. This is an old movie. Surprisingly, very little remains of the original materials that were done on the program. So it'll be a little blurry, but I'll kind of narrate through it, give you some idea of what the airplane looked like flying. Come on, you're going to do it. Yeah, I'm sorry. It doesn't. For some reason, it didn't come up. Maybe play with it here a little bit later. Not sure. Anyway, the competition lasted only about 90 days. The flying portion of it lasted about 90 days. And the YF-22 was selected as a winner to be developed into the F-22, which we know is the Raptor today. It was a competition for a large contract, so we were isolated physically and did not communicate with each other. Nonetheless, the chief test pilot for the YF-22, Dave Ferguson, was a good friend, personal friend, and we made a vow before we started the test program that if there was a common problem that could affect both airplanes, we'd let the other guy know so we could take steps on our end to make sure that we didn't put at risk our own pilots, and when we held to that. But the outcome was in favor of Lockheed. So let's talk about the transition from a prototype to an actual production airplane. Somebody once told me, well, it's such that your mother wouldn't be able to tell the difference, but this is the prototype, and this is the production airplane. Production, prototype. Prototypes, production. And they do look very similar. The realities are they are very, very different. This is from the YF-23, but it's a similar sort of picture for the YF-22. When you build two airplanes, you're not going to build customized everything. You're going to go the cheap route, get what you need to demonstrate. In our case, the shape could have good aerodynamics, so we're going to demonstrate that. The rest of it, you do it on the cheap. And if you look over here at the contributors, we took parts from the space shuttle, helicopters, F-18, F-15, landing gear, and so forth, and used those to build that airplane, as did Lockheed for theirs, all to keep the prices down. The other thing about a prototype program is it has different objectives. This was to demonstrate to the government that the potential was here for these airplanes. Lasted about 3 months, as you can see, and we had less than 100 hours on 2 aircraft. To take an airplane and put it in the hands of an operational pilot, you expend quite a bit more time and energy. 8 years, 5,000 hours, there were 9 aircraft used in the full production program. So you had an airplane that was physically different. It had all the omniscient sensors in it, which the prototypes had none, and it had to be placed in the hands of the operator knowing that nothing could harm them no matter what they did with the airplane. We started the program in Marietta, Georgia in 1997, first flight. And after the first airplane, we moved them out to Edwards Air Force Base where the bulk of the test program was done. The airplane proved to be extremely well behaved. Flying qualities were excellent. This is one of the tasks where you find the flying qualities are very demanding from a pilot point of view, and if you can't air refuel, you're not going to be able to fly good formation and some of the other things that require great precision. But the F-22 was probably one of the easiest airplanes I've flown, and we tested on both the KC-135 and KC-10 with good results, and used air refueling every day in the test program. Another aspect of is high angle attack. These airplanes have to be well behaved when you take them to the extremes of their flight envelope, either very fast or in this case very slow, and they can't do anything untoward like go out of control and damage the airplane or the pilot. So we have special programs, and we'll set the airplane up into unusual attitudes and do things with it to make sure that it can recover. And assuming this guy is going to work, here's a short video clip of it. The green that you see on there is a view through the pilot's heads-up display, and it gives him the altitude and airspeed. It's not really important here as much as just simply seeing the airplane fly. So please work. There we go. The airplane is taken to conditions of zero airspeed with various kinds of throttle conditions, slamming the throttles from idle to max. Here's one just simply falling backwards through its own smoke, stops, backs down, and it will come out flying. It doesn't always do that in the test program, and you have to go back and tweak the flight controls. But when you're finished, we had an airplane that had what was called carefree abandon. No matter what the pilot did with the stick or the throttle, you couldn't hurt the airplane or the engine. It would simply obey your commands. And when we get to the air show, I think you'll see just how much confidence the operators had in the carefree abandon airplane. Oops. One other segment on testing is weapon separation, and what you're interested in here is will the weapon come off, and will the weapon come off the airplane cleanly, not fly back up and collide with the airplane? What happens when the rocket exhaust motor kicks off and you swallow it down the engine? A lot of engines don't like that. What happens at various speeds and angles of attack and roll rates? And this next video will give you some idea of what this kind of testing looks like. The weapons are all carried up inside. Again, that's for stealthy reasons. The weapons bay door opens and the missile comes out, and off it goes. Remember the Buffs, when they opened their weapons bay doors 1 minute before bomb run, they could be seen by radar, and the same applies for an airplane like this. So the weapons bay doors actually open and close very quickly. There's a gun mounted internally, the old gun from 1915, updated to be a Gatling gun. They carry flares. That's what you see going out here. We had to shoot the missiles and drop things while we're in a roll. Here's a roll with an AIM-9 going out. More flares. The airplane at high angles of attack will cause the missile to pitch off like here and start to oscillate. But you have to test all those conditions because the operator will. I think there's a final sequence coming up here of 2 missiles. There's 1. There's 2. It can ripple launch up to 6. And there's just a kind of a neat shot with the tracers coming out of the gun. A lot of things we can't talk about. Stealth technology is obviously highly classified. The omniscient sensors are highly classified. We feel like we've done a pretty good job with the airplane, stealthy-wise. Okay. It's hard to believe, but from the time the contract was first let for those prototypes until the first operational pilot took an F-22 up on his own, it's 19 years. These airplanes are computer airplanes. Everything from the brakes to the launching of missiles and flight controls are all done by computers. How much does a computer change in 19 years? So one of the challenges we have today is we have these long gestation periods. We have this really short timeline in the driving technology, which is computers, and we've got to learn to do it much faster if we want to field relevant pieces of hardware. But the airplane has turned out great. We hear nothing but plaudits, and it was originally designed to be at least twice as effective as the F-15. Early on, when we were doing simulations, we would come out scratching our heads at night saying, this isn't about being twice as effective as the F-15. This is like 20 or more times as effective as the F-15. And sure enough, that's the way it has come out. It's a remarkable piece of engineering. So with that, let me give you a little short picture of the air show. And Dan, if you would, bring up my audio there, and let's take a look at what it looks like today. We need to have it up a little higher. Is it okay? Yeah.
Most people in America right now, when you're in about airplane practice, think, okay, it's real expensive and I'm one of the big things for us is to go out and be able to show the American public, the American taxpayers, what they've been hearing about for the last however many years. One of the biggest things that we need to show people is that the jet is, in fact, much more capable than the other aircraft that we have right now. And the only way to do that at an air show is to present people maneuvers that look unique. Aircraft really is the next generation, and it's the future for combat aviation. It was basically been flying for the last couple of years, and it's taking that and that's put it all around and cool. I think it's really significant. When I come out of crowd at 1,500 feet and 250 knots, which is obviously hard to achieve in fire aircraft, so then I pull up in the vertical, and instead of doing a regular loop like people are used to seeing, I get to about here, and then I execute a massive performance pull, and my nose actually gets back to the horizon and almost double the altitude that I went to start at. And that is just not normal for a fighter aircraft, especially in the lab. It's called a pedal turn when I execute it, but it looks like I'm sinking like a rock because the jet is just rotating in a flat rotation. Most people think that either I'm in a spin or I'm out of control, but in actuality, the jet is in complete control. I'm telling the jet what I want to do, and it's moving and flight control to make it happen. And people really, I think, are amazed at that one when I'm such a situation, and also I just push the nose on and I'm level off the building. Privilege for me to be able to see the reaction out of people already once they finally see this jet out there and see what it can do. It's been incredible.
Okay. So, interesting thing is people always ask me, well, is this better than the MiG-29 or 36 or whatever? The problem is that this airplane, if you go back to what we originally said, is designed so that they can't see you. And so its effectiveness is done stealthily. It just goes out and people fall out of the air and they don't know what hit them. This is an air show. This is very impressive, to be sure, but this is not how the airplane fights, and it's not how the airplane wins. So somebody can dream up someday how to show people all this exotic, super secret stealth and avionics at an air show. Will be in business. But until that time, this is all you can see as a taxpayer that you get for your money. But I can assure you it's far more than what was here.